Object-oriented programming is full of misconceptions, is full of mistakes and bad practices that has become, for some reason, very spread all over the world. A lot of people fall into these mistakes, and this is a problem, a big problem in our industry. And today I want to explore this with you. I want to explore the original definition of object-oriented programming, which are the heuristics that this paradigm is based on. And I want also to explore some good practices, good rules that we can use to avoid to fall into this mistake. So here is Dan. We are back in Learn Agile Practices. This is a new English episode of the weekly Pomodoro, my weekly 25 minutes with you to discuss about software engineering topic in technical excellence, agile practices like TDD, pair programming, object-oriented programming, domain-driven design, etc. As you know, I'm alternating Italian and English, so this week we are going on English, and I'm going back to a very important topic for me. I've written a lot about this lately. You can also have a check at the newsletter where I wrote about object-oriented programming in the last weeks, and I explored more in depth the heuristics of object-oriented programming that I will also briefly discuss today. But now, before starting, let's go with the intro. But first, remember, leave a like if you're on YouTube, subscribe to the channel, share the video with every programmer or any other people interested in programming that you might know. Do the same if you are on podcast, and thanks for following and listening to me. And now intro, and then we start. Okay, here we are. So, object-oriented programming. Why I said that it's full of misconceptions? Well, because it's true. There are a lot of practices that are now pretty shared between a lot of developers that are pretty experienced with this paradigm, but still fall into these misconceptions or mistakes in general in understanding the real objective of object-oriented programming. So first of all, I've asked myself why this happened, because we are in 2024 and still object-oriented programming in 35 years is now still so hard to learn, still so hard to understand for developers. And I believe that, as I said, first of all, there are some misconceptions and errors that has become, for some reason, normal and now are spreading all over the world. So when you learn from a person that is falling into these errors, then you learn with this error. And you also learn that this error is a good idea. So it's easy and fast to spread mistakes in the world. And I also think that we still have to understand, in general, in the software development world, what is the best way to learn programming to new people. And so we fall in error and mistakes when we try to learn to new people. So there are different problems, different situations that brought this misconception to spread all over the world. And what are some of these misconceptions that I'm talking about? The main example I can make is that getters, setters, public properties are usually considered a good practice, are usually even considered a standard. Some people just create a class and the first thing they do when they add a property is also adding a getter and setter for that. And we even say and justify this in a lot of blog posts or books even. We justify this by saying that it's enforcing encapsulation, which is a real fake news. It's just fake, it's just wrong. But the problem is that people really think that it's a good idea, that it's a good practice, that object-oriented programming wants us to create getters and setters. And this is a misconception. Some other examples of misconceptions can be, for example, that most people think to object-oriented programming mostly as building with classes, and also favoring, the whole favor composition over inheritance. A lot of people only use inheritance. And the problem here is that you should use inheritance for the kind of relation that is A. So when a class is a class A is B, so you can use inheritance. So I'm thinking, for example, if you create a dog class, you can extend from an animal class because a dog is a animal, right? Dog is an animal. So it makes sense also from a semantic point of view that you have something to inherit in the dog class from the animal class. You still need to be careful to what you are inheriting here, but still the basic idea, the starting point is correct. On the other side, uh, you shouldn't, for example, say that a dog is a leg or is a paw, or is a tail. A dog has a tail, has paws, has legs. It's a different type of relation. So in these kind of things, you shouldn't have a dog class that inherit extending from a tail class, but should be two different classes, dog and tail, or dog tail probably, depending how generic it is. And then the dog has a property that its type is the tail. So a dog has a tail. This is the two different kind of relationship that you want to put in place, but most people just use inheritance just to share code between classes that need to do similar things, and that's just wrong. Another kind of misconceptions can be that, for example, most people think that it's a good idea to use the interface prefix when they give a name to an interface, which is wrong again, and uh, we will discuss more about this later. But here the problem is that we are leaking implementation details, but also putting a technicalities in the name. The fact that that is an interface is just a technicalities. Usually we do this because then we need to find a name for the first implementation, and this way we can just, for example, create a interface, I don't know, interface dog, and then we can create a dog class because the name dog is free. But actually, the best approach, the better approach, the good approach is to call the interface dog, and then you need to have a descriptive name for the concrete class. So for example, if the first dog you have is a border collie, you will call the class border collie, and the border collie will implement the dog interface. Okay, I'm into dogs today with the example. Yeah, I have two dogs, so it's easy for me to think about them probably, but it was just a random example that came in my mind now. And some other kind of misconceptions, for example, one more can be that returning data usually is considered a good practice instead of exposing behavior, which is just wrong. Okay, but I don't want just to tell you that those are wrongs. I want to explain why. So why those examples are bad practices. Let's start from the original definition of object-oriented programming. The original definition of this paradigm is that we should build a system of objects communicating to each other through messages. In this context, in the context of software, messages are the public methods. So the classes, the objects, should communicate to each other only through public methods. Okay? And that's not all, anyway, because in this way, we are still not proving that those examples I made are wrong. We need to add some things. Okay? For example, we need to add the heuristics that the OOP paradigm is based on, and are mostly two. The first one is the tell don't ask principle. Objects should ask other objects to do things for them. Okay, they should ask to execute a behavior and eventually also return some data that I need as a result of that behavior. But in general, me as an object should ask to another object to do something for me. The mistake here is that we usually instead ask for data and then implement the behavior by myself. For example, I could have I don't know, a calculator class where I'm storing the current result of the previous calculations and also the new calculation that has been requested. So for example, I have 0 and now they are asking me to sum 2 and 3, and instead of having the bad approach would be to get the data that the class is storing, so getting the 2, the plus, and the 3, and then executing the sum outside of the class. So I am the service class that is using the calculator class, but I only use it as a data, basically, and then the service is implementing the behavior, reading the data from the calculator. This doesn't make sense. The correct approach here is that the calculator should only expose the behaviors, okay? And the behaviors are, for example, the sum. The sum should be a behavior. So I should ask the calculator to execute the sum, because the logic of how to sum two numbers should belong to the calculator class, okay? Then, of course, I also need a way to show the result, but it's still a behavior. It's like print the result or express, draw, write the design in a certain format, the result in a certain format. That's the point. It's still a behavior. It's not just give me the data. It's show it to the user, show it to the screen, show it in a command line tool in any case, okay? But the point, again, is that the calculator class owns these behaviors and implement them. And from outside, you ask to do those things to the calculator class. The second heuristics of object-oriented programming is instead the law of the meter. It's also called in a couple different names, for example, the principle of least knowledge or the don't talk with strangers principle. The point here is that we have a system of objects, right? So we have a lot of objects. And for example, the service needs the calculator to ask him for how to sum two numbers, okay? To do this, the calculator doesn't only need to know how to sum, but also need to somehow store somewhere in the memory the two numbers that the user asked for, the calculation, the type of calculation that the user asked for, also the previous results, because maybe you are summing more number over time, or also, for example, just the final result, because at some point you want to print it somehow. The calculator could implement this in a various list of multiple ways. It could be in the RAM, so in the non-persistent memory. It could be in a persistent layer, like a database or whatever. It could be in Redis, which is still a persistent layer of cache, usually. It could be in a lot of different places. It could be in memory. I just don't care. If I'm the service and I need to ask the calculator to do that, I only need to know what behaviors the calculator is providing and how to call that behavior and what result I will receive in return. That's it. I don't have to care about the implementation details of how the calculator handles it. And for example, I don't need to know the collaborators that the calculator is using. Is he using a Redis library to store on Redis, or a database library to write on the database? Is using an ORM, is using direct SQL in the specific dialect? I don't know, I don't care. I shouldn't know it, because if I know it, I can make a mistake. What I can do, if the calculator gives me access not only to its data, which is the tell don't task, because I can do the sum outside of the calculator, but I can also maybe access its collaborators. So for example, let's assume he's writing on a database, I can access the database client. And so from the outside, I cannot only do the math by myself, but I can also save the data on the database or read or do mixed stuff. This is wrong and it's problematic, not only because it's not safe, because you will spread all these behaviors and multiple accesses all over the system, but also because you are giving free access to everyone to your internal details, and it's wrong. The class need to only expose behaviors. The client of that behavior don't need to know and doesn't care about how you implement that, what are the implementation details, what technicalities you are using to implement that. Doesn't care, okay? Those are the two heuristics, and with these two heuristics on the table, we can now start to understand why, for example, it's important to favor composition over inheritance. Because with inheritance, I'm getting it's an easy way to share code, but it's also exposing all the behaviors of the father, which is good only in some situations. It's also easy to understand why getters and setters or exposing data, it's a problem, because we want to communicate only through messages. Getters and setters are fake messages. They are data sharing masked by behavior. Okay, a getter is the same as a public property. I can read it, and if I also have the setter, I can also set it, so it's just the same. Okay, so in some time, of course, there are special cases. We need to highlight that there are some situations, there are some patterns that allow this, and it's fine, but those are special cases. Think about ORMs. They implement the active record pattern, and it's fine. That's a solution for a specific problem that is avoiding additional boilerplate, because otherwise you would have to implement a second class to only describe how the table is done, etc. So it's a simplification from some point of view, and it's just a compromise, as always. Another compromise is the DTO or data class approach. Sometimes you just need to describe a data structure, and it's a good idea to do it via an object, a class, because you don't want to talk via primitives, right? But you need to accept that that class sometimes just doesn't have any behavior. It can happen, but it should be a special case, a very special case. Okay, so maybe it also it's born sometimes classes born as just data classes, and then new behavior raise up, and then they become a good home for that behavior. It depends. But the important thing is that we need to be aware of the compromise of having such class, and also that it's a special case. That's not the standard. The standard should be having a class with both state, which is hidden to the outside, and behavior, which are exposed to the outside and use eventually the internal state. Okay? And that's what object-oriented programming is and should be for everyone. And once we state that, there is one last element that I want to add, that we usually talk a lot about clean code. So what really clean code means? Clean code, basically, if you look at the book, from Uncle Bob, and you try to understand that based on what object-oriented programming is, then basically clean code is code that respect the heuristics, the tell-don't task, and the law of Demeter, and then additionally it's also easy to read, easy to change. That's the whole point of clean code. And if we want to achieve clean code, what we want to avoid are those that we call code smells. Code smells are just the signal that we are breaking an object-oriented rule or heuristics. For example, we might have message chain, which is the code smell, the specific code smell for the law of Demeter. In message chain, the class A makes a request to class B that returns another object, which is class C, and then class A can call C dot whatever, etc., etc. You can make a chain call. This is wrong, this is a problem, and this is the code smell that directly refers to the law of Demeter. So That's the target of code, clean code and code smells. And I believe that there is one element that can help us in two objectives. The first one is avoiding code smell. The second one is learning object-oriented properly. I think there is one element that no one talk about, almost no one, and I really think that should be one of the first thing to make people learn when they are trying to learn object-oriented programming. The object calisthenics rules. This is what I'm talking about. The object calisthenic rules are just a list of 10 rules, very simple. I will leave you links to all the things I'm saying today, some articles about object-oriented programming misconceptions, the heuristics, the definition, but also code smells, and especially on object calisthenics, because I want to focus on that in the last 5 minutes of this episode, because these rules, I think that a lot of people doesn't even know they exist. I didn't know until like 5 years ago, so it means that for 6 years I worked and 11 years ago I learned object-oriented programming and no one ever told me about these rules. And after 6 years of work, I was still struggling in mastering object-oriented programming because I was falling into these misconceptions that I talked with you today. And then I discovered these rules. And you read these rules and you just think, hey, this is not the object-oriented programming that I was taught, that I learned over years. It's not what most people is doing. And this is the problem. Because those rules are meant to ensure that you respect the heuristics of object-oriented programming and you avoid code smells. So one of the best things happened in my life is that I read a book called Agile Technical Practice Distilled, which is a book made to teach you programming, the best agile practices. The idea of the authors is to teach you through the book, and they are very good at it, and they start from object calisthenics. Why? Because those rules that are very simple, you can learn them very fast, and they lead you to the proper understanding of object-oriented programming, because they ensure that you respect the heuristics and that you avoid code smells. So since they are very easy, they are rules such as do not use the else statement or only one level of indentation. So if you have an if nested into another if, you should extract it and put it in a different method, for example. They are very simple. You can learn it quickly. You need to make some practice on them, of course, but they will drive you through the real understanding of object-oriented programming. So I strongly believe that we should use the object calisthenic rules coupled with the correct definition of object-oriented programming and the two heuristics to start and to make every people that wants to learn object-oriented programming make their first steps through those concepts. Because I think this way we can learn object-oriented programming, we can teach also object-oriented programming to others without falling into the misconceptions that I talked about today, without also letting these misconceptions spread still in the entire world. This already happened, and it will be very hard to remove such mistakes from the code base all over the world. It will be probably impossible, but I strongly believe that we need to improve how we teach programming in general, but also object-oriented programming. And to do that, I strongly believe we should use these rules. I also love the name of the rules because they refer to the calisthenics sport practices. And the reason I like it is that this sport take its name, calisthenics, from two Greek words, if I remember they're Greek, which are kalos and stenos. Kalos means beautiful and stenos means strength. So the point is that doing calisthenics as a sport will make your body beautiful and stronger. But the same applies to object calisthenic rules and your code. Because thanks to those rules, and thanks to the fact that you will more easily respect object-oriented programming heuristics and rules, and you will more easily achieve clean code. Your code will be beautiful, meaning more readable, and strength, meaning more maintainable. So you achieve these results. I don't want to say that these rules can solve all the problems. It's not. They are very simple rules, but they are powerful because they are ensuring that your path through object-oriented programming is now going in the right direction. Okay, and this is very, very important. Learning the rules and then starting to noticing every time you are breaking the rules or someone else in the code base before you is breaking the rules. It's a very important feedback to understand where there might be problems in the code base. I strongly believe in the powerful of these 10 simple rules, so I really, really want to strongly suggest to you all to have a look at the links in descriptions because you can deep dive into those rules. And I didn't want to go deeper into that here because it's harder to do it in just talk. You need to see examples to understand the rules. So I prefer to point you to some blog posts and articles, some I wrote and some from other people, because I really think that it's easier to understand them if you look at some example while you read the rules. So that was the topic. It was my thoughts about the misconceptions around object-oriented programming. So please let me know what you think. You have the usual ways. You can go in my social media, especially LinkedIn, in the post that I use it to share the episode, and just comment it. You can use the comment on YouTube if you are watching the video on YouTube, or you can join the Telegram channel, because the Telegram channel is the best place to start a conversation about an episode of the podcast or an article from the blog or a new issue from the newsletter. Okay? So please go in the description. You can both enter the Telegram channel, join the newsletter by subscribing, it's free, etc. So please have a look to everything and all the content I offer through Learn Agile Practices. Thanks everyone, remember to leave a like, subscribe, etc. and see you next week. Bye bye, and until next time, happy coding.